I think we can start now, this point. So, my name is Juan Cacho Alonso. I work by Rittal, and I support the subgroup of rear door heat exchanger. I'm here because John Fernandez is not able to be here, and I will present this PowerPoint. So, what we do in this group? So, our goals is to contribute the documentation, products, and so on about the rear door. To reduce the barrier to implement the liquid cooling in the data center, and one important goal is to harmonize with our groups of OCP all standards, definitions, connections of the rear door. It will be more easier if we speak with each other to connect everything, because the rear door is not only a heat exchanger, it's in the rack, have some fixing points, and we have to consider everything, and not everything around the rack, everything around the data center. So, in our activities is to define the operating conditions of the rear door. For example, to define, which is the maximal or the best temperature to run the rear door. Now we are working with, or we are thinking to work with 27 degrees Celsius with the rear door in order to reduce the energy consumption, or to define the methodology in which we calculate the heat exchanger. Also, a heat exchanger have not a power. So we can say, this heat exchanger have 10 kilowatts, but by which temperature? Depending on the temperature, have 10 kilowatts, or 20, or 30, or 100. So if we define the methodology in which we calculate the power of the heat reject of the rear door, we will be able to compare different solutions. And this is a very important point. We have to define the solutions for Open Rugby 2, Open Rugby 3, different racks, different fixing points, and this is very important to consider. Not only the rack, like I said, this is very important to think about the data center. Before with John Gross, he spoke about the connections, temperatures, pressure drops. All this information is very important to define the rear door. Recent contributions. So, the past we worked with air-assisted cooling unit. This is a rear door used to cool down the water coming from the cold plates. For that use case, we need pumps to move the water for sure, but in this case, we remove the heat from the liquid and reject into the air. This is very important for data centers which are air-cooled. I think Meta has a couple of these data centers, and for them it's very important to use this technology in order to enlarge the lifetime of this facility. But it's important to think that when the rack density, the rack power density increase, the liquid is coming near to the microchip. And in this point, it's very important to think about liquid cooling, direct chip cooling rear doors. Bring some advantage. But it's not only important to define the rear door, which component moves the water from the cold plates into the rear door for the air-assisted unit. This is the RPU. The RPU is not more than a pumping unit. For sure, we need the control, we need the pumps, we need valves, but this is a pump moving the water from the cold plates into the rear door to reject the heat. And for that, we need also a specification to define, okay, connections, the power, flow rates, and so on. In that case, you can find the specification in this link here. We'll define our RPU with 4 RU, not OU. Then it's different to adapt in the Open Rack V2 and the Open Rack V3. It is possible to adapt DC current or AC current, important for Open Rack V3 with 48 volts. For sure, N+1 redundancy in all moving components is very important to consider it. And energy efficiency is also important, and this unit included the fans and everything of the cooling system should consume less than 5% of the IT gear. For sure, controls and monitoring for the whole system will be considered. One contribution from the past we will also is not open in that moment, but you will have access to this white paper in the near future. We evaluate the heat exchanger in order to look what is possible and what is today the normal solution. Let me say of the cell itself, and an optimized solution for rear doors. We calculate the rear doors in order to improve the performance, but a lot. In order to increase the temperature, the facility water temperature, increasing as well the air temperature going to the server, but at the same time reducing the approach temperature. And this white paper shows that it's possible, increasing the size of the heat exchanger to increase the performance and to increase as well the water temperature to 27 degrees. At the same time, we deploy 30 kilowatts per rack and so on. In this white paper, you can see the traditional rear door, the air-assisted unit, and the hybrid. Differences you can see here. The traditional one, you know how it's working. The air-assisted unit is reject the heat of the cold plates into the air, and the hybrid solution is connected the rear door in series with the CDU, for example, or at least with the cold plates. And this white paper demonstrates that this heat exchanger can improve it by increasing the heat load per rack or reducing the approach temperature between the fluids, which is very important to reduce the energy consumption of the cooling system. In that case, it is very important to look after one important point is if we are able to increase a lot the facility water temperature as well as the air temperature going into the server. Could be a problem to increase the air temperature going into the server because the fan power will increase as well. So in that case, there is a possibility to use cold plates to avoid this problem that, okay, increasing the water temperature from the facility water will reduce the energy consumption of the chillers and free cooling system and so on, but maybe increasing the power consumption of the fans of the server. We have to consider this point. And for the solution for this part could be use cold plates. We are working also with modular data centers. So in that case, we are working for a modular data center with 300 kilowatts and 30 kilowatts IT power per rack, IT density, power density. For that, this is hybrid cooling, so the door heat exchanger working together with cold plates. And it promotes energy efficiency. Like I say, we can increase the facility water temperature, and with the cold plates, we won't have increase in the energy consumption of the fan of the servers. For sure, Open Rack V3 is in the middle. We should be compatible, and we should use this technology in this effort. There is also another topics to be discussed. They are in the pipeline. The first one is a megawatt deployment for rear door heat exchanger. The second one is to use the rear door as a part of the data center. That is really new. We have to consider it because for some customers it's very interesting to put the rear door as a part of the facility and to move the racks to change it, to change the IT gear and everything around that without move the rear door. It's a very interesting topic. We are working also in different materials or heat exchanger. Now mostly all suppliers are using copper for the fins, for the pipes, because it's the material compatibility with the fluids is very important here. But we want to look after what about aluminum and microchannel? We can change it. What is the consequences? Can we use it with facility water? Under which circumstances, which is the boundary conditions, can we use this aluminum in the secondary loop with cold plates and so on, with water with glycol? And this is some questions we want to work on it. At least it's important to use aluminum or other materials to reduce the cost and increase the performance at the same time. So the lifetime of the cooling system is also a topic we consider, but this is in this moment on hold. So if you have interest to join us in the meetings, we are every 2 weeks at 9 a.m. Pacific time. Here I think is at 6 o'clock, from 6 to 7, 1 hour every 2 weeks. It's not a very big community, but yeah, enough people enjoy us. Very interesting, everything what we discussed there. If you want more information about our projects, our documents, you can visit the Rear Door Wikipedia and find everything we do. So, thank you very much. If you have some questions, please go ahead.
So with the rear door, there's two solutions, aren't there? Depends whether you've got cold plate in the loop. So there's what's called an active rear door and a passive rear door, isn't there? So have you is the group considering the differences between these? You know, where you have fans in the door itself, because these are two solutions, and I think there are relative merits of one versus the other. But if you've got cold plates in the loop, and that's always an issue when you've got cold plates, because should you have two water connections because of the temperatures of operation, or should you put them in series? But I wondered if the group was looking at the differences between passive and active rear doors.
Yeah. if you look after the specification, you can see that you are open to use fans or not. At least depend if, of the heat exchanger pressure drops and in which system you are using it. For traditional heat exchanger, if your system have not much power, you can use rear doors without fans. It's not a problem. If you are increasing the power, this is more difficult because you have another problems. Because if you are not using fans in the rear door, maybe you have problems in the IT gear because they bypass the air into the IT gear. In case of the air-assisted unit, it's also you have to take care because the air flow control the temperatures. So the fans control the temperature of the liquid. So without fans, it's more difficult to control the liquid temperature. It's possible, but it's not as easy. So at least it's the suppliers have to take in account if they want to use fans or not, in which case. But we consider for sure to use it. So, more questions? So, then, thank you very much.